Hello folks, Ms. Strong here, and we are ready to do the practice exam for Unit 3. So this is the actual practice exam. I'm going to be working through the problems with you and as you work on them yourself. And here we go. Number 1, is the following always, sometimes, or never true? Is x plus 1 ever equal to x plus 0? That's one to kind of think about for a moment. I think most of the time we think, no, you can never add 1 to a number and get the same thing as if you added 0 to that number. And that is my first thought. I think what I'll do is subtract 1. Actually, I won't do that. I think I'm just going to leave it at that and say there's no way that I can add 1 to a number and get the same thing as if I added 0 to that number. The only choice would be trying 0. Does 0 work when you put it in there? No. Does 1 work when you put it in there? No. You might try a negative number. Does negative 1 work when you put it in there? And you don't get a true statement on both sides for anything. So I'm going to say the following is never true. There's never a time when x plus 1 is equal to x plus 0. Write an algebraic equation for the following. The difference of twice a and 4 times y is equal to 13. So the difference of twice a and 4 times y. Twice a, 4 times y, that's their difference when I subtract them in the middle. The difference between twice a and 4y is equal to 13. I think that's the equation they're looking for there. Solve this equation. Well, I recognize that j is the variable in this equation and that I will want to get it by itself. I see negative 14 over here, and I know the way to get rid of negative 14 is by adding 14 to both sides. When I do that, positive and negative 14 go to 0. It leaves me with j equals 9, 10, 11, 12, 13, 14, 5. What I say? J equals 5. Don't forget, you can always check your answer simply by plugging it back in. So it's negative 14 plus 5 equals to negative 9. Yes, that is true. I highly recommend you check all your answers when you do your test. I'm probably not going to check them all here. Let's try this again. Looks about the same. This time we have to get rid of this negative 5. So I'll add 5 to both sides to get rid of that. Be careful, this negative sign right here needs to fall down. He did not go away. He's sitting there in front of my y. Negative 5 and positive 5 went to 0. 16, negative 16 and 5, I think I'm going to get negative 11 out of that. And this is kind of a cool step. You can think about it different ways. Some people say they're dividing by negative 1 on both sides. That works for me. That makes the y positive and the 11 positive. So y equals 11. The bottom line is when you have a variable equals some number and that variable is negative, it doesn't matter if the other number is positive or negative. You need to change the sign of both numbers to see what x is actually equal to. In other words, you don't want to stop when it's negative. You want to make it positive, and you can do that by changing the sign of the other side as well. If it's already positive, it becomes negative. If it's negative, it becomes positive. So it's that last step where you get a negative variable, change both signs. Here we go with where we need to look at something being divided by 7. So if I'm dividing w by 7, I'm going to need to multiply both sides by 7, and I can think of that as 7 over 1. On this side, it's 7 and 7 reducing, or you can think of it as 7w over 7 equals, and those 7s go away. Negative 21 times 7, that's going to send me to my calculator. 21 times 7, 147. And since this is negative, my answer is going to be negative 147. So w equals negative 147. You can put that in up here for this w and check your answer. I recommend that you do, please. I like this problem for a couple of reasons. First of all, I want you to recognize that negative 1/6m is the same thing as negative 1m over 6, and that's the same thing as m over 6 with a negative sign on it. And so that negative sign can always float from top to bottom to middle. It doesn't really matter where you put it. So when I look at this equation to solve, I think of it as negative 1, next, think of it as negative 1/6 with an m next to it equals 21. I know that I can get rid of negative 1/6 being multiplied by m by flipping it and calling it 6 over 1. And if I can make it negative, I'll also get rid of the negative sign at the same time. Oops, it's 22 though, sorry, instead of 21. So on this side, I need to multiply by negative 6, and I can think of it again as negative 6 over 1, but there's no fraction there, so I probably don't care. Now here's my work, and I'll get another pen to show you. This negative and this negative become a positive. These 6's reduce to 1, leaving me with just 1m equals 22 times 6. And my handy-dandy trusty Mr. Calculator tells me that that is 132. I see this negative, so I know my answer is negative. So 1m equals negative 132, or we could just say m equals negative 132. Here I see where x is being multiplied by 8. I'm simply going to divide both sides by 8, or whatever coefficient I see in front of the x, and just divide them away. So negative 132.8, or negative 32.8, sorry, divided by 8, and I get that x is equal to negative 4.1. Again, watching my signs, because negative 32 is divided by a positive number, you get a negative answer. You get 5 packages of paper. It costs $2.50. How much are you paying per package? Give your answer to the nearest cent. Well, if I pay $2.50 for 5 packages, then I can simply divide 250 by 5, and that will tell me how much one package is, right? So 2.5 divided by 5 is 0.5, and 0.5 is like 0.50, which is 50 cents, or 0.5 of a dollar. If I'm giving my answer to the nearest cent, I'm probably going to say 50 cents. Candy made a grade of 80 on this week's math test. This grade is twice last week's grade. What was her grade last week? Well, she made an 80 this week, and it is equal to twice the old grade. Cute equation, I think. 80 is twice the old grade. So divide both sides by 2, and then we see the old grade must have been a 40. I like the 80 better than the 40. You can kind of think of it after that, too. Is this grade twice? Is 80 twice of 40? Yes, of course it is. This question simply asks, what is the first step to solving this equation? It will give you different choices. Should you subtract 9 from both sides? Should you add 8 to both sides? Well, what you need to recognize is the first thing to do is to get rid of this 12 on the bottom, and you do that by multiplying both sides by 12. So I think the best answer here is to multiply both sides by 12. That gets rid of the fraction part of it and makes the equation much, much easier to solve. 9 times 12 is 108, and I think you can see that you'd much rather solve 3x minus 8 equals 108 than you would this big fraction thing up here. So the answer is multiply by the denominator to get that denominator to go away. What's the first step in solving this equation? Well, anytime you see any simplifying that needs to be done, then you should do that first. And in this problem, you do need to simplify by distributing the 4 through those parentheses. So step number 1 would be to distribute. Step number 2 would be to get the variables together on the same side, and you would do that by either subtracting 4x or adding 1x. So you can make them go either direction. I'm going to stop with that one because we did the part we were at. Here is a good problem where I do notice that I have variables on both sides. See how I have a c over here and a c over here. I'm going to look first and see if I can simplify anything, but I don't see anything to simplify. In other words, when I look at what's just on this side, there's nothing that I can do to simplify that. When I look at what's just on this side, again, nothing I can do to simplify. I can't put those together because they're not like terms. So I need to look at the variable and recognize, oh, I need to get variables together, and a good way to do that would be to add 4c to both sides. I could subtract 3c, but I would end up with a negative, and when I end up with negatives, I mess up, so I try not to have negatives. I take the one that is smaller so that I can add to both sides. 4 and 3 are 7c plus 4 equals my 4c and negative 4c go away, and I get negative 17. Now I'm just a two-step equation, so I get rid of this guy on the edge first, subtracting them away. 17 and negative 17 and negative 4. I think it's negative 21. This 7c is still here, so he comes down. Now I can divide by that 7, and c is equal to negative 3. Major trick in this one is to recognize the variables are on both sides, and you're going to have to add or subtract that variable to get those together on one side. This is a simple two-step equation, even though it has a fraction in it. You could attack it two different ways. You could multiply everything by 3 to get rid of the fraction first, but we are trained and taught, and it's usually best to get rid of the guy next to the variable before you try to get rid of what's with the variable. So let's go ahead and get rid of the 4 by subtracting it. It goes away here. b over 3 equals 15 minus 4 is 11. Now I can get rid of the 3 fairly simply by multiplying both sides by 3. It reduces to 1 here, and b equals 33. Again, don't be shy to put your answer back in the problem and make sure it works. Watch out if I replace this by 33. 3 over 33 is 11, and then I add 4 to it, and I get 15. So I can kind of check that quickly in my head. You'll find lots of little errors when you do that, so I highly recommend you doing it. Solve. Again, you see the distributive property. Simplification that can be done in an equation, so we should do it. So I start to solve, and I see that I have variables on both sides. Look, I have a 5c over here and a 5c on this side as well. So I need to get them together, and so I'm going to start by subtracting that 5c away. And I notice that it's the same on both sides. So look what's happening. I get an equation that says negative 15 equals 8. And that's where I go, wait a minute. There's no variable left in my equation, and I get something that isn't true. I know that these negative 15 does not equal 8. Well, that's what tells me this equation has no solution. There is no number that I can put in for C, putting the same number in for C here and here and getting a true answer. So there's nothing that works for this. It has no solution, and I know that two things happen. First, the variable goes away, then I get a true statement. There are a couple of weird examples, and I don't know if I have one in here, so I'm going to point one out. Actually, I probably should go to the next slide because it might be on there. Let's see. Nope, it's not. So let me point one out. Sometimes it happens like I have like 5c plus 3 equals 5c plus 3. And if I just start solving that, I get rid of the variable. And here's a situation, you see the variable go away, but I get something that's true. 3 equals 3. And that tells me that anything will work in this equation. It doesn't matter what I put in. And I call the solution to this type of equation all reals. We say all real numbers will go in and make this work. So here's what the lesson is. When you get two numbers, when the variable goes away and the two numbers don't look the same, you have no solution. When the variable goes away and the numbers absolutely match like they do here, then you have all reals, any number as a solution. So let's keep going. We need to now find the value of x. Well, the first thing we need to notice is that this guy is a rectangle, right? And that if I'm looking for the value of x, I should probably recognize that 2x is equal to 20 because it's a rectangle. Then I would easily divide each side by 2 and notice that x was equal to 10. Not bad, right? We'll do the same thing with the y values here. Set them equal and then solve for y. Two consecutive odd integers have a sum of 44. Do you remember that when we have two consecutive integers, it just means one number after the other. So we call the first one x and the next one x plus 1. But if we need two consecutive odd integers, it means we're going to skip a number. So the first one's x, but the next one is going to be x plus 2. I had another one after that, it would be x plus 4. In other words, I'm always going to be adding 2 to the original number to get to the next odd number and the next odd number. Okay, so I have two consecutive odd numbers, and one of them I'm going to call x, and the other one I'm going to call x plus 2. And I know that their sum, when I add them together, is 44. So I can write an equation. X plus 2, that's adding together my two integers, is 44. And now I can solve that equation. Add the x's together. 1x and 1x is 2x. Plus 2 equals 44. I have to subtract 2 from both sides. And I get 2x equals 42. Sorry, I can subtract 2. Yeah, 42. Now I can divide by 2. And I get that x equals 21. So the first of my odd integers is 21. And the next one must be x plus 2, or 21 plus 2, which is 23. It's asking what's the larger of the two numbers, so I would have to say it's 23. Main thing to remember here is that the first number is x, and if they're odd, the next one's going to be 2 more, or x plus 2. Now we need to look at ratios. Which ratio is not equivalent to 20 over 30? So guys, what I would probably do is pop most of these into my calculator. I would first pop 2/3 into my calculator, or 20 over 30, recognizing that they're the same. And when I do that, 2 divided by 3, I get 0.66666666666 repeating. At the end, my calculator pops it as a 7 because it's rounding it up. Well, which of these is equal to that? Well, I've already kind of established that 2/3 is equal to that. If I multiply the top and bottom of 2/3 by 2, I would get 4/6. So I'm going to say that one's 0.666. I think I recognize that if I multiply this one times 3 and times 3, I'm going to get 12/8. So I think it's this one I'm going to check first. And when I look at it carefully, I go, oh, 4 over 8, that's a half. And a half is not the same as 2/3. So that's the one I'm going to pick. It's not equivalent. If you wanted to just pop them all in your calculator and see which one didn't match, you can do it that way too. Now we have two ratios that equal to each other, so we have a proportion. And our quick, nice way for solving the proportion was to multiply top times bottom and set it equal to top times bottom. So in this case, I get 9n is equal to 36 times 11. And that is 396. Then I have 9n, so I know that I have to divide by 9 on both sides to get n by itself. And I see that n equals 396 divided by 9, or 44. Looks like a big problem, but it really turns out to be fairly straightforward. Top times bottom will equal top times bottom. You can only do that when you have a proportion, or two fractions equal to each other. This one's going to be a little bit trickier because watch, when I say top times bottom here, that's easy. 110 times 12 is 120. But when I multiply this direction, I want to make it very clear that I have to use the distributive property. I have to say 5 times x minus 1. So 5x minus 5 is what I end up with, equal to 120. And again, I solve just this like a normal two-step equation by getting rid of the negative 5 at the end by adding it away. So 125 equals 5x. Divide by 5 to get the variable by itself. And I think 125 divided by 5 is 25, but that's the kind of thing I muck up a lot. Yep, 25. Can we do more? Of course we can do more. Which proportion best represents the following. John bought apples at a rate of 3.5 pounds for 50 cents. So 3.5 pounds cost him 50 cents. So this is the number of pounds over the number of cents, right? They want to know at this rate how much would 2.8 pounds cost. So I ask, okay, when is that equal to 2.8 pounds? What would the cost be? Now let's see which of those tends to match the one I have, because they can write them in different ways. And one of the ways I can tell if mine's the same is to think about that cross multiplication piece. So let's look first just to see if they have one that looks just like mine. All of theirs have 0.5 on the top. So that kind of stinks because mine has 0.5 on the bottom. No big deal. I can take mine and say, oh, well then I'll put cents on top and put pounds on bottom. Well, on the other side, that means I'll have to change it too and put a number of cents that I'm looking for on top and its number of pounds on bottom. Okay, now let's check again, see if I look more like what I see over here. I look like I'm matching this one exactly, and I have it here. So here's what to remember. See here how I choose number of pounds over cents? But they chose cents over number of pounds. We can go either direction, but we need to write them consistently. In other words, if I put cents on top over there, I better put cents on top over here. I can't do one equation one way and one equation the other, which I think is what's happening right here on this one. This one has cents on top, but pounds on top over here. And that won't do. That one will make that one come out goofy. Okay, almost done. Let's keep going. Write as a decimal. Well, I hope you remember the Dr. Pepper method. If I'm given a percent, I think of my dot here, and I go, oh yeah, that means I need to move it back here to get a decimal. So my decimal is after the 40. I move it back twice, and 40% must be equal to 0.4, and it is. How about Kim had a meal at a downtown diner which cost $10. She tipped 15%. How much of a tip would she leave? Well, $10 times 15%, but I can't multiply by percentage, so I have to move my decimal back and multiply 10 times 0.15. I think we will find out that $1.50 is the tip. Last year, there were 100 seniors at Lemon High School. This year, there are 145. What is the percent increase? Do you remember that percent increase or decrease, in this case increase, is equal to the difference over the original times 100. So the difference was when we subtracted the two things. So last year there were 100 seniors, and this year they think there's 145. So I'll say 145 minus the 100. Then I want to divide by the original number. The original number is how much there were originally, 100. And then times the 100 because it's a percent. And it's that times 100 that gives me a percent. Well, this one's kind of interesting. I could do all the math, but I do recognize that these 100s are going to cancel each other out. And 145 minus 100 is going to be 45. So this is going to be a 45% change. You can do it by doing all the math, but I just recognize the shortcut in that one, so I took it. Patrick bought a pair of jeans which originally cost $44 at a 25% discount. How much was marked off the original price? How much was marked off? So how much was the discount is the question, not how much did he pay. Well, he paid 25% or 0.25 of or times $44. Let's see if we can do that. We could also say, and I remember doing this in a demo video for you, that 25% is 25 out of 100. So we want to know, if we're trying to do 25%, we want to know what's 25% of 44. So our total is 44, and we want to know what percent would that be. So we could think of it like that too, in which case we do the same thing. 0.25 times 44, and we get 11. So if I was going to leave, if I was going to get a discount of 25%, then the discount would be $11. If they asked me how much would I be paying after that, then I would be paying those $44 minus that 11, or $33. So be careful again, the question that you're being asked. Another equation to solve, but this time I notice there's more than one variable, and I am being asked to solve for x. So I need to get rid of the guy next door first and get rid of the thing right in front of my x last. The guy next door goes away by subtracting him away. I can say minus my y on both sides. On this side it goes away, leaving just 3x. Over here, don't add them together. You can write it in any direction. I'm going to choose to write 18 minus 9y, but don't put them together because they're not like terms. We still want to get rid of our 3, and to do that, we need to divide each individual piece by that 3. So here I get x by itself. 18 divided by 3 is 6. 9 divided by 3 is 3. So there I have solved for y. I've got a y by itself. I have solved for y. Whoops, sorry. I have solved for x, gotten x by itself. I've solved for x in terms of y. I didn't solve for x with a number, but I solved for x if I know y. So we say solved for x in terms of y. Again, I need to solve this equation, but this time I'm going to solve it for y. So it's this guy that I want to get alone. No big deal. The 2x is sitting next to it, so I will subtract that 2x away. And look, y is going to fall down and be by itself right away. This time I'll write negative 2x plus 9. I can write it that way, or I can write 9 minus 2x. And I hope that by now you recognize that these are both saying exactly the same thing. The commutative property says I can use the order as long as I keep my 2 negative and keep my 9 positive. I've done that here. My 9 is positive, my 2 is negative. Absolute value equations. The thing to remember about them is to write them twice. The first time, we just take off the absolute values. The second time, we have to do 2 things. First, take off the absolute value, then change the sign of the guy over here. So if he's over there by himself, I'm going to change his sign. Now, I'm going to get 2 answers by solving these 2 equations. The first one solves by adding 2 to both sides, y equals 17. This one solves by adding 2 to both sides. This time, negative 15 and 2 gives me negative 13. So, if the inequality at the top is true, then y has to equal either 17 or 13. And they'll write the solution set in your answers, by the way, like this. They'll say, here's the solution set that works in this equation. They'll write it as a set with those cute little brackets that obviously I draw for you. The formula for the volume of a rectangular box is volume equals length times width times height. They have given us the volume, they have given us a length, and they have given us a width, and they want us to isolate and find the height. So, volume equals length times width times height. Volume is 400. I'll plug it in for the B. Length is 12.5. I'll plug that in for the F. Width is 8. And I don't know what my H is, so I have to leave it out. All I need to do is multiply 12.5 times 8, and that's 100. So 100 times H equals 400. Then I can divide by 100 on both sides to isolate the H, and H is equal to 4. I can plug that back in right here for that and see if I get a true statement. This is our last one, guys. We have one more to solve, one more inequality, one more absolute value equation to solve. I'm going to do the exact same thing I did before. I'm going to say 3n plus 5 equals 7 for the first equation. For the second equation, I'll say 3n plus 5 equals negative 7. When I solve these two equations, I will have two answers for my absolute value. So subtracting 5 from both sides, 3n equals 2. 7 minus 5 is 2. Divide both sides by 3. One of my answers is 2/3. Is it okay to have a fraction answer? Of course it's okay. How about this guy? Subtract 5 from both sides again. 3n equals negative 12. Divide both sides by 3. And I see that n is equal to negative 4. So I do have two answers. I'm pretty sure that most of your answer sets are going to write that like this. 2/3, comma, negative 4, inside of brackets to show that that is the solution. So that is a solution. Really sorry, let me try that again. Putting those two numbers in brackets makes that the solution set for this equation. Both of those answers will work for it. Okay, guys, if you can do all the problems that you saw in this review, you will be able to do just fine on your homework, on your Unit 3 exam. There are a few more questions on your Unit 3 exam, but they're repeats of what you see on here. These are the skills that you need. Please come ask questions before you take your exam. When you've gotten all your questions answered and you know how to do all the problems here, you'll be ready to go take it. Good luck. See you later.